Here we go. All right. So section 4.2, we're going to find sine, cosine, and tangents of various radian degrees. It's very exciting. Well, yes. You're going to have to know SOHCAHTOA. But we're also, I'm going to show you how not to memorize your unit circle. If you know your special right triangles, how many of you know your special right triangles pretty well?
Is that like the 3, 4, 5?
Those are your Pythagorean triples. So do you remember these that we wrote on our circle on, was this Friday that I did this? So if you know these two triangles, and that's all you have to memorize, you can do the whole circle, okay? And then really all you have to do is this first quadrant in your circle, and you can reflect anywhere around here. So I'm going to use the circle, and I'm going to use my special right triangles to help me find sine, cosine, tangent, and all of their inverses. Cosecant is the inverse to sine. Secant is the inverse to cosine. Cotangent is the inverse to tangent. And when I say inverse, what do I mean? Reciprocal. Opposite would be sign change. Inverse is a reciprocal. No, not the same thing. All right. So let's just start going through all of these. On here, you'll see me creating a right triangle here. So even though that's 1, 0, technically I'll extend this out until I can make a perfect right triangle there. So I'm going to look at this as being 1 right here. You'll see as I do it. You'll understand what I mean. Because we have an x value and a y value. Wouldn't this length be the y value, or I'm sorry, the x value? And wouldn't this be the y value? Okay. And so that's where all of these came from. So if you have an ordered pair of x, y, and that's what that ordered pair is there, or that's what this ordered pair is here, wherever the terminal side of your angle is, so remember this angle opens, wherever that terminal side is, you end up with an ordered pair up here on the circle, correct? That's what this ordered pair is referring to. So if I have, look at this circle over here, if this is my x and this is my y, wouldn't this ordered pair right here be x comma y? So that's where this is coming from. We create, every time you can create a special right triangle. And so we took a triangle, this triangle here, right out of it over here. This is your angle, right? And so for this triangle, y is side opposite, x is side adjacent, and what's 1? Your hypotenuse. Your hypotenuse is always 1. So for sine, isn't it opposite over hypotenuse? So y over 1, which is y. Cosine is adjacent over hypotenuse, x. And then tangent is opposite over adjacent, so y over x. And then cosecant, don't mess cosecant up with cosine. Cosecant goes with sine. Secant goes with cosine. So all we did was take the reciprocal of y over 1, we got 1 over y. X over 1, 1 over x. Y over x, x over y. So oftentimes, if I have to find the cosecant of something, I'll find the sine first. Boy, that air conditioner is getting worse and worse every day. So oftentimes you'll see me finding the sine of something, and then if I really need the cosecant, then I'll find the inverse of that. All right, so let's go ahead and go through and look at a lot of this stuff. All right, so if I'm finding all 6 trig functions, so we need to find, and so we're going to write it down here. Maybe I'll make each one of these in a different color. So I have to find the sine of pi over 6, the cosine of pi over 6, tangent equals, and then cosecant, secant, and then cotangent equals. Now we all know that pi over 6 is what degree? You have to know your pi over 6, your pi over 3, and your pi over 4. You have to know what degrees those are. So pi over 6 is what degree?
30.
Okay, so this is a 30-degree angle. Its radian measures pi over 6, its degrees is 30 degrees. So the ordered pair to 30 degrees didn't we figure out that on Friday that it was radical 3 over 2, 1/2? What did I say the x value of your ordered pair was? Do you remember? Cosine. It goes alphabetically. And then this is your sine. So you could memorize your unit circle and do it that way, right? Or, so you could use that ordered pair, or you could make the special right triangle. So I'm going to make a triangle in my unit circle. So because I'm going pi over 6, isn't pi over 6 a positive direction? Right? So I want to go 1 pi over 6 up here. So I end up in quadrant 1. It's really important to know what quadrant you're in, because x and y change signs in different quadrants, don't they? You need to pay attention to that. So I'm going to look at this as being in, I'm going to put my little quadrants here. So this is pi over 6, right there. Because this is a 30-degree angle, what's across from 30 degrees in your special right triangle? 1 rad 3 or 2? 1, right? Across from your 30 degrees, because that's what pi over 6 is, you have 1 across here. What's your hypotenuse? 2. And this would be 60 degrees here, right? What's across from there? Rad 3. Now remember that this is your coordinate grid. So isn't x and y both positive in your coordinate grid? So your x is a positive rad 3, your y is a positive 1. Your hypotenuse will always be positive no matter what. Okay? So now if I want sine, instead of memorizing my unit circle, I can just find sine right here. So sine is opposite over hypotenuse. Isn't that 1 over 2? Wouldn't the cosecant be the inverse of that? 2 over 1, which is just 2. So once I find one, I found the other. My cosine is adjacent, which is radical 3 over 2. What's your secant? 2 over rad 3, but can you have rad 3 in the denominator? No. Whoops, let me move that out of the way of the numbers there. So you have to rationalize. So you actually get 2 rad 3 over 3. Rad 3 times itself gives you just the number under the radical, and then these we just multiply together. So if you do have a rad in the denominator, you do have to rationalize it. And then what's your tangent? Opposite over adjacent. So 1 over radical 3, how does that rationalize? Rad 3 over 3. And then what's your inverse going to be? Now, I would use this as my inverse rather than this. Because wouldn't that be easier to take the inverse of, flip it, and then you don't have to rationalize it? Does that make sense, why I'm doing that? Nod your head. If you're all stuck, you got to raise your hand. Don't let me fly by you, because I will. If you say nothing, I won't stop. Question.
How do you do that?
How to do which one? This one here?
Yeah.
Rationalize it by rad 3. Whatever is in your denominator, multiply top and bottom by that radical. Because I have a rad 3 in here, a radical times itself always gives you the number under the radical. Isn't that really the square root of 9?
You're getting rid of the radical.
Yes, you have to get rid of the radical. And the square root of 9 is 3. Anytime I take a radical times itself, I get 3. Is that your question? So can I go on to the next one? Are you okay with that? Okay. So then let's look at this one. This one is 5 pi over 4. Look at your unit circle. We have to count how many fourths? 5. So we're going to take our unit circle, and I want you to figure out what quadrant it's in. That's really the most important thing. So starting here at 0, count by fourths. Isn't this 1/4? 2/4? 3/4? 4/4? Isn't this 5/4? Okay, so you could fill out your unit circle here if you wanted to. So this becomes 5 pi, where do I want to put it? 5 pi over 4, right? Then, I want you to look at the reflection across here. What's the reflection across here? What's the ordered pair? Rad 2 over 2. Wouldn't this be rad 2 over 2 also for both of those? But your x and your y in quadrant 3 is what? Negative. This is going to end up being negative radical 2 over 2, negative radical 2 over 2, only because I know what's in the first quadrant. So you could do it that way, right? And isn't your sine negative radical 2 over 2? I'm sorry. Sine's over there, negative radical 2 over 2. And isn't your cosine also negative radical 2 over 2? Question.
I don't know, since I didn't wear my glasses, but does that say like under 30 degrees, that's in the square root of 3, square root of 2?
Square root of 3. Yep. All right, so you could do it that way, or again, if you don't want to memorize your unit circle or you don't like using it, a lot of people like to do special right triangles. So because 4 is what degree? What degree is 4?
25.
Not 25.
45.
45. Yeah. Sorry, thought you said 25. Gracious. All right, so I'm going to do right here. Here's my coordinate grid. I'm going to create my right triangle here. And here's where theta is. That's my 5 pi over 4. This is my theta right there. So if that's 45 degrees, what's on your special right triangle? What are the legs? 1s. But this is -1 here because it's x is negative on this side, isn't it? What's this leg? Positive or -1? It's -1 because isn't y negative in the third quadrant? And then your hypotenuse is square root of 2. Right? So then write out your sine. Sine of 5 pi over 4. Cosine of 5 pi over 4. Tangent of 5 pi over 4. Equals. Then cosecant. 5 pi over 4. And yes, you have to have the 5 pi over 4 in there. Secant. 5 pi over 4, and cotangent, 5 pi over 4.
What if you have one over there?
Because it's what you're taking the tangent, sine, tangent, and cosine of. Whatever you're taking it of, you have to have that in there as part of your answer. So the sine of this is, you can't just say sine equals. It's a bad habit to get into.
I don't know, this is most superfluous.
Well, you need to do it or you're going to get it wrong. Because as we go further along in this, if you quit putting that in there, you're going to forget it along the way and you're going to get a wrong answer. So, you know it is, put it in there. So don't just put theta, because you can't just have sine with nothing in there. Some kids will do sine of theta, it equals, but I want to know what theta is. Theta is 5 pi over 4. Okay? Alright, so then, sine is opposite over hypotenuse, so it's -1 over rad 2, but what did we just discover that was? You have to rationalize the denominator, right? Negative rad 2 over 2. You can go the long way if you want to, but why? And if this is 1, if this is -1 over radical 2, what's the cosecant? Flip -1 over radical 2, the unrationalized part. Yes.
My past skills are very close to them.
No, you can't. That must mean that they're not here to sign you in. Because somebody has to sign you out.
My pocket just passed my mom said that she called me and
I'm not legally allowed to let you go. Because here's what would have to happen. You'll have to sign out and take my pass, go down there, and come bring the pass back up. So I can't legally let you go without a pass. Tell your mom to call the office. Go out in the hall and tell your mom to call the office because I can't let you go without a pass. Okay? All right, so do you understand why these are the reciprocals? Look at the unrationalized answer here, right? So wasn't this unrationalized answer -1 over radical 2? All I did was flip it, and don't I get negative radical 2? I will always flip the unrationalized one, because who wants to flip this one? Then you have to re-rationalize it, right? All right, so what's cosine? Isn't it the same thing? Isn't it cosine is over here, adjacent is -1, hypotenuse is rad 2. So we still get negative radical 2 over 2. And so that means that the secant is also negative radical 2. But what's the tangent? Yeah, because your tangent is -1 over 1, opposite over adjacent, which gives you +1. Which cotangent then? What's the reciprocal? 1. 1. Now we have your radians, and this is in radians, is 0. At 0 degrees, what's the ordered pair? This is, well, at 0 radians or 0 degrees. 0 radians, isn't that right here? Do you see what I'm saying? Isn't that also 0 radians? So what's the ordered pair? 1, 0, and our degree is 0. So for this one, we need to look at the ordered pair of 1, 0, because that's a weird one. This is a weird one. So remember, this is cosine and this is sine, right? So I'm going to go ahead and do sine of 0 equals cosine of 0 and tangent of 0. And this is in radians, not degrees, although degrees is the same as radians in this case. And then cosecant of 0, secant of 0, and then cotangent of 0. Hopefully Paris, the office will actually call. So sine is 0 just based upon our ordered pair, right? So that's, if you looked at it as a fraction, wouldn't it be 0 over 1? So what's the reciprocal of 0 over 1? Nope. Flip 0 over 1. You get 1 over 0. Can you have 0 in a denominator? So this is 1 over 0, which equals undefined. I'm going to squeeze that in there. It's undefined. Cosecant is undefined at 0. It does not exist. So what about cosine? What's your cosine? 1. It's the x value of your ordered pair. And then that's 1 over 1. So what's the secant? 1. So that's okay. Then your tangent, remember tangent, and I'm going to put this off to the side. Remember tangent is opposite over adjacent. So you can see that. Opposite over adjacent. So isn't tangent y over x? Right? So y is 0, isn't it? Y is 0. X is 1. So what's the tangent actually equal? What's 0 over 1? 0. So flip 0 over 1, what do you get for cotangent? Yeah, again, it becomes 1 over 0, which is undefined. So out of the 6 trig functions that we're looking at, 2 of them are undefined. So it can happen. Okay. All right, look at pi over 2. Do you still need that? You okay?
Yeah.
Okay. So then look at pi over 2. Isn't pi over 2 also, we could use 90 degrees if you wanted to, but isn't pi over 2 one of those special points? In other words, your special points are your north, south, east, and west points on your unit circle. What's the ordered pair at pi over 2? 0, 1. If I were you, I'd be using that ordered pair. I wouldn't use a special right triangle. So I'm going to use the ordered pair of 0, 1. So which one of these is my sine? The 1. So this is cosine and this is sine. So you tell me what the 6 trig functions are for that one. Do you have them yet? All you're doing is looking at your ordered pairs and then flipping them for the second half. So here's the left side. Sine is 1 and cosine is 0, right? And then tangent is y over x. So 1 over 0 is what? Undefined. So then if you take the reciprocal of 1, you still get 1, don't you? What's the reciprocal of 0? Undefined. And what's the reciprocal of undefined? 0. Are we looking for her?
Chris?
Yes. Y'all have no runners this period. Thanks, Kathy. All right, so then for negative, now we have a negative pi over 6. The answers are not the same as A. Why? Where is negative pi over 6? What quadrant? Yeah, if it's negative pi over 6, aren't we dropping down clockwise this direction? Right? So when you look at, it's almost the same numbers, but your signs are going to be different. So if you look at your coordinate grid here, pi over 6 is going to go down here. This is where theta is going to be. So that is negative pi over 6 right here. From here to here. So that's still a 30-degree angle, but it's negative 30 degrees. So if this is 30 degrees here, what's opposite that in the special right triangle? What's opposite 30? 2 rad 3 or 1? 1. You either know it or you don't. If you don't memorize your special right triangles, then you have to memorize your first quadrant. It's your choice. Do one or the other. So across from 30 is always 1, but in this case, this is a y. So is that 1 or negative 1? Negative 1. So if this is 30 here, this is 60 here. So what's across from 60? Is this a positive rad 3 or a negative rad 3? It's positive because x is positive in the fourth quadrant. And then your hypotenuse is always positive. So now you're ready. So just look at your signs. For sine, we've got opposite over hypotenuse. Isn't it negative 1/2? Right? Isn't that the opposite sign of what we had over here? So which cosine? I'm sorry, cosecant. Negative 2. So flip it, right? Your cosine is adjacent, which is radical 3 over 2. But that one's positive, right? So cosine is positive in quadrant 4. Secant would be 2 over radical 3, right? Yep, but we have to rationalize. So rad 3 over rad 3. So we get 2 rad 3 over 3. Still positive. Is tangent going to be positive or negative? So side opposite over adjacent is negative 1 over radical 3. What does that rationalize as? Negative rad 3 over 3. So use your unrationalized one to flip over here. What do you get? Negative radical 3. So not everything was the opposite as over here, correct? Only some of them. So you can't necessarily take the opposite of what you did in A. Some of them were opposite, some of them were the same. So do you see this part here on your unit circle where it has A, S, T, C? Right? A stands for all. S stands for students. T stands for take. And C stands for calculus. Why does that sound like I have, that looks funny. Calculus, no, it's right. Weird. All students take calculus. It also stands for all sine, cosine, tangent. This stands for sine being positive. Sine is positive only. All the rest are negative. Oh, I just said that backwards. Sine is the one that's negative. Why? What's your x value? Negative. And what's your y value? Positive. So if you're doing opposite over hypotenuse, oh it is, see, I'm going crazy, sine is positive. Jeepers, creepers. I didn't think about this before I did it. So I don't memorize this stuff, I just look at my quadrants. All right, so take tangent, isn't that y over x? What's your y? Negative, and what's your x? Negative. So doesn't that make tangent positive? And then cosine is going to be your positive one in quadrant 4. So that kind of helps you, so you have to remember everything. All right, so look at this one here. So we're not going to go through all of this, but let's just talk through a couple of them. So this time we went negative 7 pi over 4. What do you have to do first? What's the most important thing to know first? What quadrant is it in? So we're going to take our unit circle and we're going to start counting 7/4, but in the negative direction, right? So we're going to start here and we're going to go 1, 2, 3, 4, 5, 6, 7. Don't we end up in quadrant 1? So essentially, this is the same as pi over 4. No different. Because it ends up in quadrant 1. So we're not going to finish this one, but wouldn't you go and do the whole same thing for that one? Right? Which one would you have? Oh, so it'd be like B, but B was in the 3rd quadrant, so we'd have all the same things. You just have to figure out your sign. So if all of them are positive, wouldn't you have all the same answers? But they'd all be positive? So if you've done it over here, you have the same answers over here. But these ones are all positive because it's in quadrant 1. So once you do it for sum, then you don't have to keep doubling your work. So now look at the back. Now you're going to use your period to evaluate sine and cosine. So a period is equivalent to 2 pi. That's 1 period. 2 periods would be 4 pi. 3 periods would be 6 pi. So if I want to figure out what sine of 13 pi over 6 is, rather than counting it the whole time, split it into its mixed number format. So this is the same as the sine of, how many times does 6 go into 13 evenly? Twice. So I've got 2 pi plus, and then how many would be left over? 1. Wouldn't that be 2 pi plus pi over 6? True or false? Okay, so what that's saying is on your unit circle, you're making, starting from here, you're making one full revolution, and going an extra pi. Won't you be left here in quadrant 1? Okay, so they're asking for sine and cosine. So sine of pi over 6 is equal to, now you can look at what you did before, or you can just know you have a 30-degree angle, right? So here I am in quadrant 1, not memorizing anything. Here's a 30-degree angle. I have 1, radical 3, and 2. Sine is opposite over hypotenuse, so what is it? Opposite over hypotenuse. So it's still 1/2, right? Then what else do they want? Cosine? So what's cosine? Adjacent over hypotenuse, rad 3 over 2. Have I memorized anything? No. But the more of these that you do, the more you're going to say, oh yeah, sine of pi over 6 is 1/2 because I've done it a zillion times. All right, you find cosine is 17 pi over 4. Split it into periods. How many times does 4 go into 17? Start with that. This time you got 4 pi, right? Isn't that 2 full revolutions? So where does pi over 4 end up? What quadrant? Quadrant 1. And aren't all sine, cosine, tangent positive in quadrant 1? Do you remember what sine and cosine is in quadrant 1? We've done it twice on the other side. Remember what it is? If you don't, then whip this out. Here's your special right triangle. 45, right, is here. That means there's a 45 here. So this is 1, 1, rad 2. And isn't sine opposite over hypotenuse? So sine of pi over 4 is equal to 1 over radical 2 is rad 2 over 2, isn't it? And cosine, you should start to learn, is also the same exact thing, pi over 2, or square root of 2 over 2. Negative just means you have to pay attention to what quadrant it's in. So sine of negative, what? 2 goes in there 4 times, right? 4 pi plus a negative what? Pi over 2. So negative pi over 2 means we're going here, right? So we're right here, aren't we? What's that ordered pair? 0, negative 1. And isn't this cosine sine? I'm going to have to do a special right triangle. Sine of negative pi over 2 is negative 1. And cosine of negative pi over 2 is, did I just do that backwards? No, 0. Good. Questions before we use our calculator? Are you getting the idea? All right, take your calculator. We have to make sure that we're in radian mode. Where do you find that? Yep, go to mode. When you reset your calculator, it automatically goes to radians. The other day, you might have changed it to degrees. So scroll down to radian, hit enter so that it's now highlighted. And then go second quit. If you're putting radians in, your calculator needs to be in radians. If you're putting degrees in, your calculator needs to be in degrees. So you're going to have to switch back and forth. So to find the sine of pi over 4, I know that it's radical 2 over 2, but here's what we're going to do. Put in sine, so press sine, and then you want pi divided by 4. So second function pi divided by 4 in parentheses. See what you get. Now, didn't we say earlier that it was square root of 2 over 2? So we'll also take the square root of 2 and then divide that by 2. What do you get? Same value. So wouldn't you agree that it's giving you the correct answer? Okay. So we want to go to, let's just say 4 decimal places. You have to pay attention to what they really want. So 0.7071, right? So find the cosecant of 1.3, and that's assumed it's in radians, not degrees. If it were degrees, they'd put a little degree symbol. So how do you do cosecant? Well, you could do it one of 2 ways. You could do 1 over, cosecant is the inverse of what? Sine, right? So 1 over sine of 1.3, you could do that. Or what else did you say? See here above sine it says the inverse sine. Do second inverse and do 1.3. What do you get? Oh, doesn't. Why? Because you'll find that that is not. The inverse sine is not cosecant. All right, so you're going to use, oh, we don't have the correct one in there. Oh yeah, we do, right there. So you're going to do 1 point what? 4 decimal places. What does it go out to? So you might want to put in your notes that you did 1 over the sine of 1.3. And you got 1.037. Is it stay at 8? Yep, 8. So try cosine. You need to find that some of these don't actually have a sine or a cosine. And when we look at their graphs, you'll find out why later. So that one does, it's negative, right? Negative 0.1288. And then the rest of this just deals with these right here. So odd or even. So we've got cosecant and secant are even. And all that does is look at this. If you find the cosine of a negative radian, you're going to get, it's the same as finding the cosine of its positive radian. Same thing with secant. Do you remember when we were doing this over here and we were comparing these two? Which ones were the same? Which ones were the same? Cosine and secant were the same as the original, right? Whether we took the sine of a positive pi over 6 or the cosine of a positive pi over 6 or the cosine of a negative pi over 6, didn't we get the same answer? That's what this is telling you over here. You get the same answer. But for the other four, sine, cosine, tangent, and cotangent, they're all considered odd. They'll have opposite signs. So if you're taking the sine of a negative, it's the same as multiplying the sine of the regular one by -1. So whatever one is, it's the opposite of the other one. So we'll do a couple of these. We'll see how far we get. So sine of t is equal to 1/3. So if the sine is 1/3, what's the sine of opposite t, or of -1/3? What would be the sine of -1/3? Would it be 1/3 or -1/3? Look over here. So if this is the sine of just plain t, what's the sine of -1/3? Wouldn't you have to multiply this by -1 to get the sine of the negative? Right? So what's this times -1? What's 1/3 times -1? So you get -1/3. So if this is a sine, we've got cosecant. What's the cosecant of t? If the sine is 1/3, what's the cosecant? What are sine and cosecant to each other? Nope. Well, look at this one first, though. What's the cosecant of 1/3? Right. Take the reciprocal. So the cosecant here would be 3. So what's the cosecant of -3? So aren't they also the same as sine? So it would be -3. Oops, you can't see that part. Sorry. All right, look at cosine. Remember, the cosine is the one that stays the same, right? So the cosine of -t is equal to -1/5. So what would be the secant? Because that's the inverse of cosine of -t. What's the secant of -t? What's the inverse of this? -5, right? Because it's still negative. So what's the cosine? Same or different sign? Look over here. Cosine, don't we get exactly the same? And aren't these exactly the same? So cosine will be exactly the same. Cosine will still be -1/5. Whoops, 1/5. And secant will also be the same. Oh, they asked us for negative secant, didn't they? So isn't this -5? They asked us for this one. If they asked us for secant of t, what would you have written? Also -5. All right, last one. Does sine change or not? Yes, it does. So sine of -t is this. What is cosecant of -t? Just take the inverse of this. 8/3, right? So they're asking for the sine of t. Isn't the sine of the t the opposite of this? Aren't these opposite of each other? Opposite signs? So if that's 3/8, isn't this -3/8? And then what's the cosecant of t? -8/3. So really all you have to remember is that cosine and its inverse secant stay the same. All the others just change the sign. All right, so I want you to